Today's notes are over 1.8 inequalities. Okay, that means if there's not an equal sign, it's going to be a greater than or less than, or greater than or equal to, or less than or equal to sign. That's what inequality means. And guidelines for solving inequalities are step 1, move all terms to one side. Step 2, factor. Step 3, find the intervals. Step 4, make a table or diagram using test values. And then step 5 is to solve by checking intervals and endpoints, and we will do some examples with that today. The second set of notes you need to write down is some other information about solving nonlinear inequalities. This means when x has an x squared or an x to the third or something like that. So basically there is a sign of a product or quotient, there's a pattern there. So the first thing is, if a product or quotient has an even number of negative factors, then its value is positive. If a product or quotient has an odd number of negative factors, then its value is negative. Okay? That kind of makes sense because if you multiply negative numbers times each other an odd amount of times, the answer always comes out negative. And up here, the first one, if you multiply negative numbers an even amount of times times each other, you always come out with a positive value answer. Okay, so we are going to put this into practice and it will make much more sense. All right, our first example today is example 3, solving a quadratic inequality. Solve the inequality x squared is less than or equal to 5x minus 6. So the first thing we need to do is get everything on one side. And then that's step 1, okay, remember, and then if you go back and look at your steps that you just took notes on, step 2 is going to be to factor. So if you want to do a t-chart, that's going to be 6, and then what numbers multiply to 6 and add up to negative 5. You're going to get x minus 2, x minus 3 is less than or equal to 0, so that's factored now. And then the step 3 is to find the intervals. So now we need to split this into intervals. Well, we know that the solution to this would be x equals positive 2, and the solution to this one would be x equals positive 3 in order to get 0. So our intervals are, let's see, I'm going to take a little note of what our intervals are. They are from, here's 2, right? Our only 2 points are 2 and 3. And then we have some bigger numbers past 3 over there and some smaller numbers all the way to negative infinity over here, okay? So now this might look familiar to you. We are going to make the table or diagram, which we just started, and then we're going to start checking endpoints and intervals, okay? So, well, I know that when I plug 2 in, I'm going to get 0 right here as this is going to equal 0, okay? And I know that when I plug in 3, that is also going to equal 0. And remember that our answer on this side needs to be less than or equal to 0. So those two answers are both going to work. So whatever our final outcome is, 2 and 3 need to be included in it because their answers work because this is a less than or equal to sign. Okay? And then we just need to have some test values. So over here I'm going to put my test value of 1 because it's less than 2. Okay? And then over here in between these two I'm going to make my test value 2.5. And then here my test value is going to be 4. And then I'm just going to start taking some notes underneath. The first thing I'm going to take note of is the sign of x minus 2 and the sign of x minus 3. Those are my two factors here. So I'm going to make a little, so I should have left myself a little bit of room here. X minus 2, X minus 3. Okay, and then when they are multiplied together, because that's what we need to do on this side over here, what does our final value come out to, okay? So when we plug in 1 for x minus 2, we get a negative 1. So our answer here is a negative. And then for when we plug in this test value 1 to x minus 3, we get another negative. Now remember our rule. If you have an even number of negatives, so a negative times a negative, you're going to come out with a positive. Okay, so when they're multiplied together, it comes out to a positive answer there. Okay, and the same with this middle value, we have to do the middle one. 2.5 minus 2 is going to give me a positive 0.5. 2.5 minus 3 is going to give me a negative 0.5. And positive times a negative, that's an odd number of negatives. Our answer is going to be a negative value down here. Okay, so this is the most important answer that you get to. Okay, then let's test number 4. 4 minus 2 is still a positive. Oops, sorry. 4 minus 3 is still a positive. A positive times a positive is still a positive, okay? So remember, our answer needs to be less than or equal to 0 to be true. So which of these spots is less than or equal to 0? Well, 2 is equal, so that one, let me use a different color. So 2 is equal to 0, so this should work. 2 is going to work, okay? And then 3 is equal to 0, and that's going to work. And this whole section in here, between 2 and 3, because we did a test point, is going to work because it's less than 0. Its final answer is always going to be less than 0. So the only places that work are 2, in between them, and 3. Okay? This doesn't work because it comes out to a positive value if you plug anything in over here, which is always going to be greater than 0, and the same on this side. Okay? So now we need to write out our answer. In the form of a solution. So that is going to be written like this. So let me go ahead and write it down here. It is written like this. The solution is x at any point when x is greater than or equal to 2, but also needs to be less than or equal to 3. So that's one way to write it. You also need to be able to write it in interval form, which is just between 2, there's only one spot, between 2 and 3, and it includes 2 and includes 3, so it's brackets. So that's all your answer right there. The next example is example 4, solving with repeated factors. So it's a similar question. Solve the inequality x times x minus 1 squared times x minus 3 is less than 0. Okay? So we can skip step 1, which is get everything on one side because it's already there, and step 2, because step 2 is to factor and everything's already factored. So we can actually move down to step 3. But I'm going to write step 1 is done, step 2 is done, so we're going to move on to step 3. So step 3 is find the intervals, and then step 4 is make a diagram for them. So I know that basically you just need to find the roots of this side. So I know that the x needs to be x equals 0 for this one, x equals positive 1 to make this equal to 0, and x equals positive 3 to make that one work. So let me leave a little bit of space above it. All right, so space over here. My 3 numbers are 0, 1, and 3, so 0, 1, and 3, and then I need values above and values below, so that covers every real number value. And I just need to make sure that I like to look at the intervals first that we put here. So if you plug in 0 up here, you know your answer is going to be 0. Okay, so I'm going to write equals 0. And you could solve it if you want. It's just 0 times whatever these are is going to get you 0. And remember that you don't Remember that it doesn't include 0 here. It just says answer has to be less than 0. So actually, I already know that this one's not going to work, this specific spot, just the 0. And let's do the same thing for 1. When we plug 1 in up there, it equals 0 because we just found these as the zeros. So obviously, these answers are all going to be 0. And then if you plug in the 3 up there, it's going to also be 0. So none of those will matter. They will not be a part of our answer, whatever the answer is, okay? All right, we can go ahead and find some test values. So test value, we'll do -1 right here. We'll do 0.5 right here. We'll do 2 right here, because it's in between 1 and 3. And then we'll do a test value of 4 over here. Now we need to list our factors on the side. So we've got x. And we've got x minus 1 squared. So that one's the one that's going to be confusing because we have to multiply twice in that one. X minus 3. And then all of them together, x minus 1 squared, x minus 3, okay? So let's start with x, and let's start with -1. When you plug in -1 for x, you're going to get a negative value. It's going to be -1. Okay, when you plug in -1 for this one, you get -1 minus, -1 minus 1, which is a -2, okay? So you get a negative value in here, but as soon as you square it, negative times a negative becomes a positive. So that's how we get a positive here. If you want to take a little note, you can. Negative times a negative equals a positive, okay? But what we want is just that positive value, okay? And then if you plug in the -1 here, you get a negative. And then when you get a negative times a positive times a negative, you get a positive final value, okay? All right, and then we'll do the same here. Plug in 0.5 for x, you get a positive 0.5. Plug in 0.5 for negative right here, you get a negative, but squared becomes a positive. Any of these squareds are going to be positives. 0.5 minus 3 is -2.5, so our final answer is a positive times a negative, which gives us a negative. Okay? If we test 2, that gives us a positive. Gives us a positive. This gives us a negative, so our final answer is a negative. And then the last one, +4, that gives us a positive. Positive times a positive, and then squared stays positive. Positive, so positive times a positive gives us a positive answer. Okay, so this means that we need to pick the values that make this side less than 0. The only ones that work are this interval here, between 0 and 1, but not including 0 and 1, and then this value here, between 1 and 3, but not including 1 or 3. So we actually need to write this as 2 different intervals. So our answer needs to be written as you can write it like this. X, if x is between 0 and 1 but not including them. So actually the best way to write this is in interval form, which is between 0 and 1 but not including them. That's why you use the parentheses. Or, that's the or sign, 1 and 3 but not including the 1. Okay, here's a hint, a quick thing. If it included the 1, if we could include the 1, we could just go from the interval 0 to 3. But unfortunately, we can't include the 1 in our answer here, so we have to write 2 different intervals down here. Okay, this is the last example for today. We have to solve an inequality with a quotient. So the example is solve the inequality 1 plus x over 1 minus x is greater than or equal to 1. So step 1, we need to get everything to one side and kind of simplify it. So 1 plus x over 1 minus x minus 1 is greater than or equal to 0. So everything's on one side. And now we have to factor slash simplify, so that's step 2. So I'm going to multiply this 1 times 1 minus x on the top and 1 minus x on the bottom. Okay, so that we can get this as simplified as possible. So 1 plus x. So now everything has a 1 minus x common denominator. And then when we multiply that negative 1 times 1 minus x, we get a negative 1 plus x, like that. Okay, and then our final answer here is 1 minus 1 is 0, x plus x is 2x, over 1 minus x is greater than or equal to 0. That's as simple as we can get it, so we're just going to leave it like that. So that's step 2. Okay. Now we can start splitting it into intervals and testing. Okay, so the intervals here, our zeros are, the top becomes 0 when x is 0, and the bottom becomes 0 when x is 1. So those are our only two zeros here. So if you want me to write that out, we can write 2x equals 0, so x equals 0, and then this one, plus x, so x equals 1. Okay, those are our two values, our two intervals. So let's go ahead and make a diagram. So I'm going to do it right here. 0, 1. Okay. And so a couple things before we get started. Remember, I like to do plug in the 0 first. That one, and remember we're looking at this final answer right here, okay, to help us out. So we've got 0. When we plug in 0, on the top we get an answer of 0. It equals 0. And since our answer can be greater than or equal to 0, whatever works, whatever interval works, we know that 0 needs to be included in it because it equals 0. But when we plug in 1 down here at the bottom, we get something on top. We get 2 divided by 1 minus 1 is 0 on the bottom. Okay, so it does get us 0, but it gets a 0 in the denominator. So when it's 0 in the denominator, actually the answer is undefined. So this one, whatever this one's answer is undefined, so it does not count in the final answer interval. So whatever our final answer is, it cannot include 1. Okay, so I hope that wasn't too confusing. All right, and now we can start testing those spots. So we need the sign of (2x) and the sign of x minus 1, and then we need the sign of 2x divided by x minus 1. Okay, which is the same rules as multiplication. So let's do a test value of -1 and a test value here of 0.5, and then this test value is 2. So when we plug in -1, we get a negative here. When we plug in -1 here, we get a negative, and the negative divided by a negative becomes a positive value. Okay, and then oh, sorry, I messed up right here at the end, sorry. This is 1 minus x, not x minus 1, 1 minus x. So actually, 1 minus -1 makes a positive value, okay? And then a negative divided by a positive is a negative. Sorry about that, okay? So I think that's the only spot I made that mistake. All right, and then we need to do 0.5. So 0.5 times 2 gives us a positive value. 1 minus 0.5 stays positive, so a positive divided by a positive is a positive. Okay, and then the last one, positive 2 times 2 stays positive. Positive 1 minus 2 is going to give us a negative. So a positive divided by a negative is a negative. Okay, remember our answer needs to be greater than or equal to 0. So the only spot that works for greater than is this middle spot between 0 and 1, including 0, not including 1. Okay, so our final answer is going to be including 0 up to 1, but not including 1. Okay? You can also write it, let's see, like this. X if x is greater than or equal to 0, but less than 1. Okay, so that's how you can write it there.